So hi everyone, welcome to my YouTube channel. In this video I am going to explain you the important topic from CSIR UGC NET General Aptitude, that is geometry. I have explained in the previous video on geometrical shapes, but this is quite different from that. So let us discuss about that, and also please go to the previous videos on the topics from General Aptitude like number series, clock and calendar problems. They may be helpful for you to solve the questions. So let us discuss branch, that is topic geometry. It is the branch of mathematics that deals with the properties, measurements and relations of points, lines, angles, surfaces and solids. So this is the very vast topic, geometry. So there are two types which geometry can be divided: plane geometry and solid geometry. So plane geometry, it is a two-dimensional surface such as circles, squares if you take. So the first one, line. There are different types of lines. So intersecting lines, you can see in this diagram, two lines are intersecting. Two or more lines that meet at a point are called intersecting lines. The common point is called the intersection. M, you can see. So concurrent lines. There are three or more lines in a plane are concurrent if they intersect at single point. Here also more than three lines are intersecting. So the point at which they intersect, we call that as the point of intersection, M. So the next, perpendicular lines. If you observe here, two lines are perpendicular to each other. They are making angle 90 degree in all the way. So a line is said to be perpendicular to one another if the two lines intersect at right angles. Parallel lines. Two lines in a plane that do not intersect and they do not touch each other. Okay, you can see here, you can extend at infinite, but they are not going to intersect and they do not touch at any point, are called parallel lines. So here we come across different angles if we take the parallel lines, and it is a traversal is a line that intersect two or more other lines. If these two are the parallel lines, if one line is intersecting, this is called traversal. Okay, then here we come across the angles. First one, if you take corresponding angles, here I have mentioned with the numbers 1 2 3 4 for the above line and the below. These two are parallel lines. So the corresponding angles, how we can identify angles that are in the same position on each line. 1 5, these are in the same position. If you compare 1 5 3 7, so 2 6 4 8, so these all are what? Corresponding angles. Alternate interior angles, angles on the opposite side of the traversal and on the interior of the plane. Alternate interior angles are what? Angles on the opposite sides of the traversal on the interior of the parallel line. So 3 6, you can understand, 3 6 are alternate interior angles. 3 6 4 5, okay, interior angles. Alternate exterior angles, so 7 2 1 8. If you take here I have written angles also, you can clearly distinguish them. These are what? Alternate exterior angles, means outside. Angles on opposite side of the traversal and on the exterior of the plane. They are opposite. 1 that is 8. They are opposite but exterior. 7 2. Vertically opposite angles. the pairs of opposite angles formed between each line and the traversal. So pair of opposite angles formed between each line. So example you can understand here 1, 4. 1 and 4 are what? Pair of opposite angles formed between each line. Okay, 1, 4, 5, 8. Or else you can take 2, 3, 6, 7 also the vertically opposite angles. So these you must know. Corresponding angle, alternate interior angles, alternate exterior angles, vertically opposite angles for parallel lines which do not intersect. So triangle which has 3 sides, 3 vertices, already I have explained in the previous video different types of triangles. So here first one comes right angle triangle, where between two sides the angle must be 90 degree and the opposite we call diagonal. The line that is opposite to this angle is called diagonal or hypotenuse. So Pythagoras theorem we can use. If you consider this as the opposite base and the diagonal as hypotenuse, uh, let us take a square as the diagonal or the hypotenuse. A square equal to what? The sum of the square of the sides, b square plus c square. This is the Pythagoras theorem you can apply for right angle triangle. Isosceles triangle means two angles are equal. If two angles are equal, then two sides are also equal. Okay, that is what isosceles triangle. AB equal to AC, angle B is equal to C. So equilateral triangle, all the angles are equal and all the edges are equal. AB, BC, CA. BCA angles are equal. Then some of the important facts you know about the triangle. Sum of the interior angles of the triangle always equal to 180 degree. If you add the angle, interior angles of any of the triangle, it must be equal to 180 degree. And next comes median. If you take the triangles, you come across these parameters: median, centroid, orthocenter, incircle, circumference of the circumcircle of a triangle. So median you can define in this diagram. A median of a triangle is a line segment from one vertex to the midpoint on the opposite side of the triangle. So here we have drawn the line segment from one vertex to the midpoint on the opposite side of the triangle. So this is what we call the median. Okay. So centroid, how it is different from median? Centroid, a centroid of a triangle is the point where three medians of the triangle meet. Here is the point at anyway, but three medians are going to meet. They are not at equidistance. So centroid is mentioned in this diagram. So O is what? Centroid. In circle, if you take a triangle, the orthocenter is the point intersection of the altitudes. Orthocenter you should know. It is a point at which the intersection of altitudes is going to takes place. AF, if you draw this diagram, you can mention these edges as E, F, G. Okay. So AF, BG and CE are the altitudes and O is the orthocenter. So in circle, the in circle is the largest circle contained in the triangle. Inside the triangle, if you draw, that is the largest circle enclosed. Then circumcircle of a triangle. It is a circle which passes through all the vertices of the triangle. If the circle is outside, it is touching the vertices of the triangle here. and the circumcenter, its radius is called circumradius. If you take the radius, circumradius. Okay, next comes circle. Circle, if you take the total angle, that is 2 pi, 360 degree. If you take triangle, 180 degree. So circle is what? Set of all points in a plane that are at a given distance from a given point at the center. Chord. How we define chord? Chord is the line that joins two points on the circle. It may be anywhere. M, N, P, Q is called chord. It is joining 2 points on the circle. Arc. An arc of a circle is 2 points on the circle and the continuous part of the circle between 2 points A, B. This is the arc. So next, tangent. If you take the circle, a tangent to a circle is a line that touches the circle at exactly one point and never entering the circle's interior. It is only touches the circle, it is not going to enter the circle. Here TQ, PQ are what? Tangent. So some of the important shapes you can observe here, and here the angle subtended by an arc at the center of circle in this figure is twice the angle subtended by the same arc at the circumference. This angle theta is twice the angle made at the center, 2 theta. In any of the problem it is helpful to solve. Then so angle subtended by an arc in the same segment, here all are in the same segment, these angles are equal. Next one, the angle subtended in a semicircle. If you take this is what the semicircle here, the angle subtended in a semicircle is always a right angle triangle, 90 degree. Okay, so then comes parallelopiped, 4 edges. A parallelogram is a quadrilateral with 2 pair of parallel sides. Okay, 2 pair of parallel sides, AD, BC and AB equal to DC. So here angles are opposite angles are also equal, A equal to C, B equal to D, and the diagonal bisect each other. In this diagram you can see, and if you calculate the diagonal, that is the sum of the diagonals is equal to the sum of squares of 4 sides. If you add these two diagonals, it is given by sum of the squares of the two sides. Rhombus also same here, but all sides are equal. AB, DC, AD equal to BC. It is a special parallelogram, and the angles, if we take opposite angles, are equal. So the other shapes here, square, rectangle, trapezium, pentagon, hexagon, different shapes we come across. If you increase the sides, then sum of the interior angle of the polygon. How we can calculate? Sum of the interior angle is given by n minus 2 into 180 degree. So n is what? Number of sides. If you take a square, n how many? 4 sides are there, and minus 2 into 180 degree. If you do interior angle, you can calculate here. So 4 minus 2, 2 into 180 degree. How much here? 360 degree is the interior angle of the square. So like that, pentagon, if you take 5 minus 2, hexagon 6 minus 2, you can calculate the interior angle. So solid geometry is, as we know, sphere, cube, cone. Let us solve some of the previous year questions here from CSIR UGC NET. So here a ladder rates. This is the question from 2014. Okay. So in this question, a ladder rests against a wall as shown. The top and bottom ends of the ladder are marked at A and B. You can see in the diagram. The base B slips. The central point C of the ladder falls along. The moment of the ladder is we can see in this diagram, where the dark dot show here. Here I have drawn the diagram. The moment of the ladder is pictured by the dark points represent momentum of the point C. It is going to what? Slip. So if you join these lines or the dots here, you will get the line CD, that is the arc of the circle, but it is quite straight line. That's why from this observation, from the given question, we can say that it is a straight line. Even though it is arc, but it is quite a straight line. If you add the dots, here the ladder is slipping towards B. That means that is quite equal to the straight line if dots if we add. Next question, three identical equilateral triangle plates of side, each one placed together such that they form a trapezium. The length of the two parallel sides of this trapezium is. So they have given three equilateral. Equilateral means two sides, all the sides are equal. So three equilateral triangles, if you join, it will become a trapezium. Okay. So length of two parallel sides, that is 5 plus 5 is equal to how much? 10 centimeter. Two sides of two equilateral sides form a larger length. So 5 plus 5 is equal to 10 centimeter. So option C is correct here. As shown in the diagram, a sphere is placed on the top of an incline. Here is the sphere. If it rolls down the incline without slipping in exactly 50 turns, the radius of the sphere is. So it is taking 50 turns. So let R be the radius of the sphere. When it rolls down one complete turn, it will cover the circumference how much? 2 pi r. Radius is r, its circumference. If it complete one turn, 2 pi r. So 50 times. Then we have to multiply the circumference into 50. 50 into 2 pi r. That is what the diagonal BC. 50 turns it will take to reach B here from C. So BC is equal to 50 into 2 pi r. Pythagoras theorem, that is BC is equal to 5 meter. They have given 4, 3. If you use this Pythagoras theorem, 3 square plus 4 square, 25. Okay. So root of 25 will be 5. This diagonal will be how much? 5. So 5 is equal to 50 into 2 pi r. Then you can calculate the radius here. So radius you will get around finally 5 by pi. Option B is correct here. So the next question, a circle of radius 7 units lying in the fourth quadrant touches the x-axis at 10, 0. The center of the circle has coordinate. So fourth quadrant, that is x-axis is positive, y-axis is negative. Center of the circle they have given, the quadrant touches x-axis at 10 comma 0. 10 comma 0 means x comma y. X 10, y is 0. So 10 comma y is here, and circle of radius 7 unit lying in the fourth quadrant. That means here it is 7 minus 7. So the origin will become x comma y, 10 comma minus 7. So option B is option C is correct, 10 comma minus 7. So there is an equilateral triangle in the xy plane with its center at the origin. The distance of its sides from the origin is 3.5 centimeter. Area of circumcircle is centimeter square. So here equilateral triangle in the xy plane with the center at the origin. Okay, this is the equilateral triangle. The distance IH sides from the origin is 3.5. How much is the distance here from the origin? 3.5. That is nothing but radius 0.35, and its diameter will be how much? 7. So OD is equal to what here? The radius 2 times the OP. OP is the distance. If you draw the circle here, O is the center and OP is given by 2 times. If you multiply 2, OD you will get. Area is equal to what? Of the circle, pi r square. So then radius is how much? 3 point, here the radius of the circumference is given by OD, that is 7, and OP is 3.5. So radius square you have to take, pi r square. 7 square, pi is 22 by 7, 7 get cancelled. 22 into 7 how much? 154 centimeter square. So option D is correct. The cube ABCDEFGH in the figure has each edge equal to A. The area of the triangle with vertices A, C and F is. So here in the diagram you can see the vertices of the cube. So join points A, C, F. Here you need to join the points A, C, F to form the required triangle. Consider triangle ABF. Here is the B. ABF. Then AF is equal to Pythagoras theorem, AB square plus BF square. So that is one of the edge equal to A. A square plus A square is equal to root 2A will be the value of AF. So triangle ABC, triangle CBF, that is also if you take the edges AC equal to root 2A, CF root 2A. So area of the triangle we need to calculate here, that is given by root 3 by 4 side square. So if we put, we will get root 3 by 2 A square. So option B is correct here. So last one, a conical vessel with semi-vertical angle 30 degree and height 10.5 centimeter has a thin lid. The radius of the sphere in centimeter is. So here is the diagram they have given. So join, let us mention the points here, AC and construct a perpendicular OD. So this is the line AC. Okay, up to C. AC is the line. We have to join here OD perpendicular to that center of the circle sphere. Clearly OD is equal to OA, that is radius R. So A must be near to here. So AC is equal to double of that. That means AC here from this point to this point at the cone angle 10.5 they have given. Angle OCD 30 degree they have given. So from triangle ODC 90 degree because it is perpendicular. So angle OCD equal to 30 degree. So from this you can make the angle here. Sine 30 degree is equal to what? Opposite by hypotenuse. Opposite is what? R, and the hypotenuse is what? OC. Then R by OC. That is OC. So sine 30 is 1 by 2. R by OC. OC is equal to what? 2R. 2 times the radius of the sphere R. So AC equal to how much? AO plus OC. So AO is R and OC is 2R, 3R. And AC value they have given in the question, that is 10.5 centimeter. So R you can calculate. R is equal to 3.5 centimeter. So radius of the sphere is 3.5 centimeter.